sine. So you look at the 3 sine x, 4 cos x, and you do the root of 3 squared plus 4 squared, which is, I should know this, memorize it by now because I've done it so many times. But so yeah, it's 5. And then what we do is we do tan or arctan 4 over 3.
Yep.
And that is equal to 53.13.
53.13. Let's say one more decimal place.
130.
Okay. Yeah, okay.
Then that would just be written as 5 sine x plus 53.130.
Okay.
Yep. And then in the grand scheme of things, that would be y equals 40 minus that.
Yep.
And I'm not too sure what to do from here.
And what were they asking you to do?
They were asking us to put in the form r sine x plus alpha, I think.
You can't do any more than what you've already done. Like this 40 can't be integrated in any way.
What if I think the bracket is squared actually. So 3 sine x plus 4 cos x is squared.
So in that case, it would be this squared?
Yes.
And that's as much as you can do, unless they wanted you to do something like sketch the graph or like find the roots, something like that. But writing it in the compound angle format, that's it.
Yeah, let me just have a look through my notes because she's a bit confusing.
Excuse me. So I think they probably asked you to like solve it when y is 0 or sketch the graph, one of those two. And I think that the bracket probably isn't squared. If it's squared, then they want you to solve it when y is 0. If it's not squared, then they want you to sketch it or solve it.
So yeah, I've checked and it is squared.
And did they say they want you to sketch it? I don't know, they wouldn't maybe solve it when y is 0?
I guess. Yeah.
Okay. So how would you solve it when y is 0?
That I am not sure of either.
So I would bring it to the other side, so it's not negative.
Okay. So 5 sine x plus 53.13 equals 40. Oh, all squared. Yep.
What's next?
Could you expand the brackets?
That'll probably make your life more difficult.
Right. X 40. Could you square root both sides?
Yep.
So that just becomes 5 sine x plus 53.13. 2 root 10.
Okay.
Divide both sides by 5.
Yeah. So how's music?
The padding still here.
He's my friend. Sorry about that. Okay, how'd you get on?
So then from here, you just do arc sine of 2 root 10 over 5.
Yep.
So you're left with x plus 53.13 equals arc sine 2 root 10 over 5.
Mm-hmm.
Which is the same as... Oops. 2 root 10 over 5, which is not real, apparently.
That's a good point. Try minus. No, shouldn't be minus. Shouldn't work either because it would be plus or minus when you square root it. But yeah,
Yeah, I'm
shift sign.
over 53.13.
Say it again.
Did you bring over the 53.13? But I'm not sure it would change much.
You can't because it's in the bracket with the sign. We're making lots of assumptions about this. So you're sure that this question is like written down correctly and
Squared, yeah.
and so they didn't say what they want you to do. Like I just assumed when y is 0, but maybe y is something else like 10 or 20.
Let me have a read through. But yeah, as I said, I was kind of working on something else, and all of a sudden this has jumped on us.
I think we just don't have the full question.
There was something before, because we were working on, 3 sine x plus 4 cos x and finding that, easy peasy stuff. Yeah, I don't know. I don't have much more info. I guess we could just leave it and I'll find out tomorrow.
So let's just... So we get an answer if it was, instead of 0 equals, it was 20 equals.
Mm-hmm. Is it in y equals 20?
Yeah, like so if y is 20.
Well, I guess we could just give y a value and work with that.
So let's say when y is 20. So
okay.
I did arc sine of that, like root... So it turned out to be root 20 because 40 minus 20 is 20 when you bring it over.
Yeah, okay, so I'll just write things. So y equals 20. That's 20 equals... and that is... So 2 root 10 minus 20.
So it happened before the square root. So it would have just been root 20 over 5.
So I bring... Oh yeah, no, I just missed out a step, so 5, sorry. That equals 40 minus 20, which is equal to the root of 20. And that becomes root 20 over 5. Then sine root 20 over 5. Which is 63.43, yeah.
Okay. What would be next?
3. And then you just bring over the 53. So you subtract it, which becomes 10.30. And that's x.
So that's one solution for x. How could you get a second one?
Since this is working in sine, what I tend to do is draw the graph.
Okay.
And the graph starts at 0. So we're looking at 10.3. So 10 here again. The line. So it would be 180 minus that. If it were to be, between 180 and 0. For 360 and 0.
180 minus what?
180 minus 10.3.
No. It would be 180. No. It would be 180 minus 63.435.
Oh, okay.
You get all your solutions first because the graph has been translated. You get.
Oh, yeah.
You keep that in a bracket. So after you do arc cos, arc sine, or arc tan, keep it in a bracket until the very end.
Okay. So I'll extend that. Yeah.
And then you would subtract 53.13 from all of your final answers.
Mm-hmm. So 63. 4. Then 180 minus 63.43.
Yeah. 0.435.
Yep. Equals 116.565.
Yeah. Remember when we square rooted both sides?
Yeah.
And so we got root 20. It was squared. So what do you know there?
That it's plus minus.
Yes. And so this is plus or minus 63.435.
Yeah. That's plus minus. I'll just rewrite this. Okay, so then you use minus 63.43 minus 53.13.
You got a second answer by doing 180 minus your first answer.
Yeah.
So now do that with the negative one.
Why can't you do that with the first one?
So you know how you did 180 minus 63.435?
Yeah.
So that was with the plus answer. Now do the same thing with the minus answer.
Oh, yeah. I got confused because I led myself to believe that the minus 53.13 was finding one again, but no. So that's plus, and that's 243.435.
Yes. So now you've got your answers. Now you subtract 53.13 from all four of them.
Mm-hmm. All four?
Yeah, so the plus, the minus, the 180 minus, and the 180 plus.
So minus 63.43 minus 53.13 equals minus 116.56, pretty obviously. And would it be minus 63.43 minus 243.435?
Say it again, sorry?
Would it be 243.435 minus 53.13?
Yeah.
Okay. Which equals 190.305.
Okay.
The one before was minus 116.56. The other one is 10.3.
Okay.
And the last one is 160.565 minus 53.13. Which equals 63.435.
Say it again.
Which is 63.435. Which is, what we found before.
Shouldn't be. So we have...
Oh, wait. Yeah, I did 180 minus 63.435, which is 116.565.
No. We're subtracting 53.13 from all our answers.
Yeah. And I did 116.565 minus 53.13.
And so what you get?
63.435.
What did you subtract it from?
I did 116.565.
0.565. $63.435. Okay. 0.435. Okay.
Is that pure coincidence?
Let me think about it. Seems strange. So we get 63. We get... So we should have... Yeah, minus that. We have something like 10. Yeah. And then we should have 116. Yeah. And it's 243. No, it's all good. 243.
Okay.
Yeah. Okay. Because I don't know where they got their stuff from. Yeah. So any questions about that?
Yeah, a lot, but that's more for my teacher because I've got no clue what they're trying to get me to do.
Yeah. So the problem is if they said like solve x when y is 20, that's what you would do.
Yeah.
Put it into the r sine x plus alpha form so you can solve it. So it's not a mixture of sine and cos. It's just sine. So now you can solve it. Just slowly but surely solve it from the outside in. So square root both sides. Don't forget the plus or minus. Divide both sides by 5. Arc sine both sides. And after you do arc sine, arc cos, or arc tan, get all of your answers, and then subtract 53.13 from all of them. Because if you had done that at the start, you would have gotten that like 10.3 thing. And so you would have done 180 minus 10, which would give you 170. And we can see that that's not one of the solutions because the graph has been transformed. It's moved 53 to the left. It's been stretched by 5. It's been squared, all sorts of stuff. So it's not its usual self of 180 minus.
Yeah, of course.
Yeah, okay. Were there any other questions that you wanted to go through that you had?
No, I don't think there are any more.
Okay.
So I think if we could now, I think we'll just work through the checklist, to be honest, because it goes from easiest to hardest.
And so, I think we've technically done at least one of each. So if you want, we can just go back to one in particular. Yeah. So radian, arc length, sector segment, solve equations, small angle. Is there any in particular?
Here it says circular measure.
So that's like radians.
I'm sure, yeah. I think we could just revisit all of them, because I think I'll have another session tomorrow at the same time, if that works for you.
Okay. So, do you have a graphical calculator?
Yep, of course.
Great. So, sketch these graphs, won't be any problem to you. Sketch these graphs, won't be any problem to you. Okay, this is one that we haven't seen a whole lot of. How would we do question 6? And I'm just kind of going down to the exam questions.
Sure. So PQR. PQ is it 12. QR 68. degrees. Now, find the. I'll just draw the triangle. Okay, so find the size of angle QRP. In your answer, radians to 3SF. You have. Yeah?
I'm just doing something else. Don't worry about me.
Okay.
Okay, go on.
So it's not a right angle triangle. Do you use the cos rule?
Yeah, well done.
So it's a squared equals b squared times c squared minus
Plus.
plus. So b squared plus c squared minus 2bc cos a, I think it is.
Yep.
And we want to find the angle QRP. So that's between that. So it's 12 squared equals 9 squared plus 8 squared minus 2 times 9 times 8 times cos theta or a. Usually I would just go to the solve function on the calculator.
Do it.
This sort of stuff.
That's what I started.
Cos x, and I get a lot of solutions. So I take the first one, which is 89.6 degrees.
Okay.
Because it's acute, right? Acute means it's within 90 degrees.
Holy moly. So what was it, sorry?
I got 89.602 among a lot of other ones, but I guess it's
how did you get multiple solutions?
I did solve n, and then it gives me all of the solutions.
Okay. Okay. Try part B, find the area.
Oh, and I had to give it in radians as well.
Oh, in radians, yeah.
So I just multiplied by pi over 180. Over 180, which is equal to 1.564. And what do you write if you want to make it known that's in radians? Do you write rad or r or something else?
It's like the degree symbol, but it's like half a circle. Like it looks like the letter C.
So you just write c?
For radians. So like if you had pi and radians would be like that.
Oh, okay.
Yeah.
So I do just 1.564 c.
Yeah.
Okay. So that's A.
So in part B, and if you get stuck on that, there's question 7. I'm just going to run to the toilet. Just be a second. how'd you get on there?
So I've forgotten the area of a triangle. The
Ah.
formula for that.
Forgotten it?
Yeah.
Area. A half AB sine C.
Aha. Yeah. Maybe sine. See, I need to remember that one. They don't give it to us, do they?
And perhaps not anymore.
Okay. So yeah, I'll try to remember that. So half AB, and we know one of the angles. So half 9, 8 times sine 1.564 because we're working in radians.
Right.
9 times 8 times sine. And that gives us 0.983.
So what two sides did you multiply by?
I did 9 and 8.
Yeah.
And would you use the sign of the radians or the degrees? Because they would give two answers, even though the area is the same.
If you'd be in radians if you have it in radians.
But what I don't get is you could use the angle. Oh, okay. Because I'm still in degrees. I prefer to stay in that and just convert to radians if I need to.
Okay.
So I use 89.602.
Yeah.
Or the equivalent of radians. And 35.99. Is that what you get?
Yeah, I believe it's 3 9s, is it?
Yeah. So
That's
36.
So 35.999. And I just used a different method. Weird method, but I got the same thing. Did
you turn your calculator into radians?
So I did it two different ways. The second way was with radians 1.564.
Yeah.
And you get it. And then I did it with my weird square root method that nobody uses.
Fair enough.
Okay, question 7. Oh, hang on.
Okay.
Hang on. So cos rule, fine. Find that. Yes, they wanted it in radians, convert it into radians, and then area is just a half AB sine C.
Mm-hmm.
So I just have to remember that. Okay, how do we do this?
So you want to find the coordinates points where the curve is the x-axis. So you replace x with 0.
Yep.
So it's y equals sine 5 pi over 6.
Mm-hmm.
And for that, do you just solve sine 5 pi over 6?
Nothing to solve. Just put it in a calculator.
Just put sine 5 pi over 6?
Yep.
Okay. That's equal to 0.04568.
I believe.
Which is in degrees.
Yep.
So do I need to multiply it to radians?
So you could just change the settings of your calculator to radians.
But how would you know when you'd need to do that and when you need to take it out?
So this is radians because it's pi.
Okay. So if I see pi...
Yeah.
Oh. When I multiply the answer by pi over 180, I get a weird number.
Was it times 180 over pi?
No, times pi over 180.
I don't know. Radians mode.
Okay, I'll do that. Shit. The thing is that I'm sometimes a bit hesitant because either I'll forget to change it back, then everything will be wrong. Or I could just easily multiply it. Yes, I get a half.
Do you? Okay.
Yeah.
Okay.
Okay.
Write down the exact
Okay,
coordinates. So that's the x-axis. So what would it be? They wanted coordinates?
so that would be half pi, right?
Does your calculator say half pi?
No, just half.
It's just half. Coordinates.
Point there. So half 0.
What do you know about when x is 0?
When x is 0,
Where's x 0?
all along the x-axis.
Y is 0 along the x-axis.
Oh, it's on the y.
So you did part B. And so coordinate.
Okay. So for this one, it would be 0 half.
Yeah, so you let x be 0 and you got y as a half.
Mm-hmm.
And that's that
That
point
makes
up there.
that makes more sense. Because otherwise, now for the x-axis, you replace y with 0. Yeah, that makes more sense.
Okay.
Yeah. X plus 5 pi over 6. What do you do here? How would you go about doing this one?
Same as any other. How did you do it before?
Use the calculator. I'm not too sure.
Try with the calculator.
But how would you do it without using the solve function?
So you're trying to get x equals?
Yep. Would you arc sine?
Yep.
To remove the sine?
Yeah.
Equals x plus 5 pi 6. And then you do arc sine minus 5 pi over 6.
Hold on.
Equals x.
So you've done arc sine to both sides. So what do you now have?
Arc sine equals
Arc sine what? It has to be arc sine
0.
something. Okay, calculator. Arc sine 0.
Oh. Can you not bring over the plus 5 pi over 6?
Just do one thing at a time.
Okay, so you get 0.
Okay. And on the right side?
0 equals x plus 5 pi over 6.
Okay, now you can do whatever you want.
So then x equals 5 pi over 6.
No.
Minus 5 pi over 6.
Yes, in theory. However, what did I tell you to do once you arc sine?
You keep it bracketed.
And get all your solutions and then do it.
So with sine, they have that graph. Do I use a normal sine graph? And then I change it later. Okay. Okay, and I look at 0, right?
Yep.
So it's 180, 360, 720, and 240.
Yep.
And it's up to 4 pi, which is 720.
And instead of 180, I'm going to use pi because we're in radians.
Okay, so pi, 2 pi, 3 pi, 4 pi. Five, 6. Yep.
Is that it?
Nope. And then from each of those, you subtract 5 pi over 6?
Yeah.
Yeah. So pi over 6, 7 pi over 6, 13 pi over 6, 19 pi over 6.
Over 6, and yeah, and you were right to, the negative 1 is outside the range, the minus 5 pi over 6. And so that's where it's from. So there's there could be a little more to other questions, but let's just deal with the question in front of us. Okay, any question? And so just to clarify, if we had gotten our first answer as minus 5 pi over 6, and then we did pi minus that, we would get pi plus 5 over 6 pi. So that's 1 and 5/6. That would be 11. We'd get 11 pi over 6, which is wrong.
Yeah. So I just need to remember after doing arc sine. Yeah. To keep it.
Yeah, because it's and that way we didn't have to do anything strange. Because we could just do our normal way of dealing with it. Do you have any questions about that last one?
No.
Okay, so this one is similar. I'm just gonna move on. Let's see. This one. Sure. Okay, let's do this one. This is sector and segment stuff.
Sure. Okay. Okay, so give that length of arc DC 6.08 and the length of R. So the length of an arc in the terms of radians, is it just R pi?
Yep. R theta.
R theta, yeah. R theta, and that is, we don't know what R is, times 1.52 equals 6.08. And then we can just rearrange that to get 0.04.
6.08 divided by 1.52?
Oh, I did 152. 4.
Centimeters. Okay. B.
And B. The perimeter of a shape. I need to find that. Okay. So you just add them together. It isn't that tough, actually. So you've got 4 plus 4 plus 6.08 plus 7.3 plus 8.6.
Yeah.
That was an awkwardly easy question.
Yeah. And you get the idea. So that's arc length. What's the other thing that they do?
What's that? Question 6.
Question 6. So then they're now beginning to mix and match stuff. So cosine rule mixed with arc length stuff. So this time you have to find the angle. Yes. The area of the triangle. You can do it if you like. I think you'll be fine with it.
I think, yeah, sure. I'll give it a shot.
Alright.
Okay. Given that the exact length of Z, given that the exact length of arc ZW, that's the arc, and okay, so they give you the arc length, and we know that R times theta equals the arc length, and we see that the arc length is 4, the radius is 4, multiply it by theta, so as a result theta is 40 pi over 9 all over 4. Which is equal to 55.85 degrees.
Radians?
Yeah, and then multiply by pi over 180. Which is 0.97.
Exactly.
Really? 0.975.
So they wanted exact value of alpha in radians.
Well, it's a long number.
That's not exact then.
I'll switch to radians and see if it gives me a fraction. So 160 over 9 pi.
160 over 9 pi.
Yeah.
Okay.
Yep. And B, the area of triangle X, Y, Z. They've given me 2 sides and 1 angle. And we said it was half AB sine C. So we could do half times 6 times 4 times sine sine 160 over 9 pi minus 2 pi minus 160 over 9 pi, right?
Yeah.
Or is it just pi minus 160 over 9 pi?
Excuse me. So how did you get your 160 over 9 pi?
So that's the that's alpha. So yeah, I do 2 pi minus 160 over 9 pi.
Yeah.
Because 2 pi is 360. Right. Then I need to do that long thing. 2 2 pi minus 160 9 pi. So that's 7.713. That's what I get.
So 7.7 centimeters squared. And how did you get 160 over 9 pi?
I did theta equals 40 pi over 9 over 4.
Do that again. 40 pi over 9 divided by 4.
40 pi over 9 over 4. 160 over 9 pi.
So what are you putting into your calculator? Like a double fraction or something?
Yeah.
Do times a quarter, because what you're doing is dividing the bottom part of it by 4.
Oh.
If you do it that way.
Oh. Okay. I did it the way you just did it.
I see. So yeah, that's a different thing. That's
Yeah.
what this is doing is times by 4, because of keep change flip. So times by a quarter or divide by 4, and you get 10 over 9 pi.
Okay. So then I'll just replace it with that.
Yeah.
Yep. So 0.5 times 6 times 4 times sine 2 pi minus 10 over 9 pi. And it's minus 4.16.
So it's just giving us a different thing. Let me just check. 0.5 times 4 times sine 2 pi.
Oh, it's because I divided by pi as well. Yeah, 4.1.
Okay, that's 4.1 centimeters squared. Yeah.
Yeah.
That's it. So yes, just do it as a separate. If you're dividing a fraction, just do it something like that, like the fraction divided by 4.
Yeah.
And basically it's times a quarter, which turns it into 40 over 36, which just simplifies that. Any questions about that one?
Oh, I get that one.
I'd love to get one more in. So this is exact size of that angle. We're good.
Could we do maybe a small angle approximation?
Yeah.
Just
Solving Trig. So small angle approximation. Okay. So let's take a look. I'll just take these and simplify. And let's just go down to exam question. Okay, question 4. Oops. I'll just bring in both 4 and 5. Okay, let's try it.
These are small measured radians. Use my find the approximate value of 1 minus 2 theta. So we would rewrite that top one as 1 minus 1 minus 2 theta squared over 2. And then 3 theta times 2 theta. And that can be simplified to 2 minus theta squared over 5 theta.
What is 3 times 2?
Oh, 6. Yeah.
Theta times. And what's theta times theta?
Oh, theta squared, theta squared.
Yeah.
And I did the wrong one. The top one wrong as well. 1. Oh, no. Did I?
So what was on top, sorry?
Let me redo it. So it's 1 minus theta squared.
On the top, is it?
Yeah.
Um,
Because the 2's cancel out.
Bidmus, you have to square first.
One minus 4 theta squared over 2 over 6 theta, which then becomes 1 minus 2 theta squared over 6 theta.
What was on the top again, sorry?
1 minus 2 theta squared.
Okay, expand. So if I was to expand the top, I would get, like, so if you're subtracting it, you can expand it by -1.
Mm-hmm.
So 1, -1, and then minus minus, so plus 2 theta squared over 2. So simplify that.
I'm getting a bit confused about expanding.
So that's all I did.
Yeah. Oh, and then the 1 says there. Yeah, I'm multiplying by the 1 that's in front. This theta squared. Equals 1 minus 1 plus 2 theta squared over 2, 6 theta squared. So then that becomes 2 theta squared over 6 theta.
Yep.
And then that can equal theta over 3. Oh, it's 6 theta squared at the bottom, yeah.
Yeah.
So then it's just a third.
Yes. That is 1/3. And if we go there, we see that tiny little a third.
Mm-hmm.
Question 4. Okay, question 5.
5. Given that theta is 3 tan is approximately equal to 2 theta. Is that divided or plus 1?
Where are you looking? This
3
here?
tan. Yeah.
Yeah, that's 2 theta plus 1.
Plus 1. Okay. Plus 1 is approximately equal to 2 theta plus 1. Okay. So first we just expand everything. So we get 3 theta minus 1 minus 4 theta squared over 2.
There's a difference. So the one above it was cos 2 theta. This isn't cos 4 theta, it's 4 cos theta.
Right. So is it 4 brackets 1 minus theta?
Yeah.
Like that. Okay. Minus 2. And then it's just theta plus 1. And then you expand the brackets. Minus 4 plus 4 theta squared over 2 plus 5.
Yep.
And then you check that bracket to make it 16 theta.
Uh, 16 theta?
16 theta squared.
Only the theta is squared, so it just becomes 4 theta squared. You're not squaring the 4, you're just expanding out the 4.
Why didn't you square the 4?
Because it wasn't. It's not 4 squared. It's theta squared.
Oh,
So,
yeah.
So up here it was 2 theta, whereas it's just 1 theta.
So then that's 3 theta minus 4 plus 2 theta squared plus 5 over theta plus 1. Then you just simplify all of that. 2 theta squared plus 3 theta plus 1 over theta plus 1.
Mm-hmm.
And then you eliminate the ones.
No, that doesn't work, Bidmus. If you have to simplify an algebraic fraction, fully factorize and then simplify.
So you solve a quadratic on top.
Yep.
Polynomial to so I get minus 0.5 and minus 1.
And so what will be the two brackets?
So theta plus 0.5 and theta plus 1.
So theta plus 1, but we need to get 2 theta. So how else could you end up with an answer of 0.5?
2 times 0.25. Or 2 theta plus 1 again.
Yes. And then?
And here you can eliminate the brackets with theta plus 1.
Yes. And so there you've shown it.
2 theta plus 1. Nice.
And yeah, I mean, you can kind of see if they told us the answer was 2 theta plus 1. We know one of the brackets has to be theta plus 1 if it simplifies. And the other one is 2 theta plus 1.
Yep.
Yeah, how was that for you, Gregoire?
Thank you. Yeah, it was good.
So did you say you want another lesson tomorrow?
Yeah, I think that would be best.
Okay. Any topic in particular or just more of this stuff?
I think it would be continuing with this stuff, yeah.
Okay.
I think I'm pretty confident on sequences.